Welcome to the 5.2 day 2 video. We're still going to be working with those same formulas, the sum and difference formulas, just an opportunity to practice them a bit more and continue to memorize those formulas. So this will just kind of be an opportunity for you to continue to practice. We are not looking at new formulas, just kind of maybe some different settings with some of these. So my recommendation is go ahead and pause the video and do a couple problems and then restart the video to check your solutions, and then you can dive deeper as you need to. But really on this one, you're mostly just going to be going through and doing some additional practice and double checking to make sure that you're doing them properly. So pause the video, do 1 and 2 if you feel confident. Also do 3 and 4 and then check your answers, and then you can move on or look for a little bit more instruction in the video if you need it. So the solutions are up for number 1 and 2. Number 1, the final answer is 1/2. We want to recognize this as the difference formula for cosine. And the reason it's a difference formula is because cosine changes from sum to difference and vice versa. From there, it's really just kind of plugging in and evaluating the cosine of pi over 3 after we simplify. Number 2, a couple different ways to do this. One way is to use a sum formula with cosine. You could use angles 30 and 45. A different way, you could use a difference formula with cosine with 120 and 45 and subtract them. Either way, you end up with root 6 minus root 2 all over 4. We could choose to factor a root 2 out of that and get an alternative form for this answer that is equivalent, something like this. It's up to you. That doesn't matter to me. Sorry, we are drinking coffee in the back. All right. Again, pause the video for the next ones and try them on your own first. See if you can, how you're doing at memorizing these formulas. Number 3 is probably worth talking about a little bit because of the simplification. So we start with the formula. We do need to evaluate our sine and our cosine for each of these angles so that we can divide sine over cosine to get the tangent. Tangent of pi over 4 is 1. For pi over 3, both sine and cosine are negative, which would divide out to a positive tangent. And when we divide the sine over the cosine, it simplifies out to root 3 over 1 or root 3. So when you plug in your values, this is kind of what you get, which root 3 times 1 is just root 3. And a good reminder from here is that this would be considered unsimplified. We are not going to be able to leave that radical in the denominator. Since it's a binomial on the denominator, the way we will rationalize this is we will multiply the numerator and the denominator by the conjugate of the denominator. So make sure you change the sign between these two terms in the binomial to 1 minus root 3 on the numerator and the denominator. And then I need to expand or FOIL or multiply this out. I'll get root 3 minus root 9, which is whole number 3, minus 1, and then plus root 3. So the root 3's are like terms on the numerator. So I would end up with a negative 4 for the integer portion and then plus 2 root 3. You could certainly choose to write that where the 2 root 3 is first and then the minus 4. On the denominator, we'd have 1. And since these are conjugates, the middle terms will cancel out. I won't bother to write them. And then minus root 9 or minus 3, which would be a negative 2. Typically, we would then divide both of these terms by the negative 2. Both of the terms on the numerator would be divided by negative 2. So negative 4 divided by negative 2 is 2. And then positive 2 root 3 divided by negative 2 is minus 1 root 3. You can choose to write the 1 or not. So it is common for students to maybe stop too quickly on this problem and to get a non-simplified answer that I'm highlighting in yellow. While it's mathematically accurate in terms of the value, it's not simplified, so you do need to rationalize this and expand it out and reduce if possible. For number 4, you would hopefully be able to recognize this. The sign on the numerator tells us that this is a sum problem. This is the tangent of 10 plus 35. We're going to add those arguments together. This is the tangent of 45 or the tangent of pi over 4. We actually just did that in the previous problem, which is 1. All right, these next ones we are verifying identities. You could start on either the left side or the right side, or you could choose to work on both sides. It's a little less traditional, but you can. It's not wrong, just maybe unique. When you're ready, so try them both, and then when you're ready, restart the video and see if you can get the same answers. So the solutions for 5 and 6 are up on the board. What I chose to do was on number 5, I worked on the left-hand side. I used the difference formula for cosine. It did some evaluation of my sine and cosine at pi over 4, and then factored out a GCF of root 2 over 2 to get this to look like the right-hand side of the equation. For number 6, to verify this, I started on the left-hand side. I used the sum formula for sine, evaluated cosine of pi over 2 and sine of pi over 2, and it ended up simplifying to cosine of x on both sides. Number 7 and 8, also some more problems for you to do some verification with, just some more practice. So try both of those and then restart the video when you're ready. The solution for number 7 is on your screen. So I started with the difference formula for sine on the numerator and then rewrote each term of the numerator over the denominator. And I ended up having some factors that reduced out. And then I ended up with 2 different tangents. Just make sure you keep the argument the same each time. Remember, every trig function needs an argument. And that completed the verification. For number 8, I just started this one. I thought it might be worth talking about. So I started off with the sum formula for cosine, and notice how that sum became a difference when I wrote out the formula. And then this minus cosine x is still here. So in order to try to get this to look like the right-hand side, and I chose to start on the right-hand side rather than the left-hand side, or I chose to start on the left-hand side. I looked at the right-hand side and didn't really see a starting place. What I decided to do was to just kind of reorganize it and look at those 2 terms. And they both have a common factor of cosine of x. So I'm going to factor that out. And from the first term, then I would have the cosine of h. And the final term at the end here, I'd have minus 1. Now I still have this minus sine of x, sine of h. And each of these are over h. Although this is written just slightly differently than this other one, it is still the same thing. I could choose to shorten up this denominator and just write it like that. And the same thing here, just that is still the same thing. So this has now been verified. It just is a really, really odd looking original expression. I don't love the way the right-hand side is written. Might help like it look a little bit better if I put in the parentheses. Technically, they're not needed because of this written out front like that. It would be multiplying the entire numerator, but it just looks a little weird to students. And so I also start worrying that this is like something else called a hyperbolic sign just because of the letter H, but it's not. Okay, number 9 has 3 different problems. For all of them, you're going to be working with 2 angles, alpha and beta, in various quadrants, and asked to find you're using some of your sum formulas for cosine, sine, and tangent. So give it a try. Restart the video when you're ready. So on the screen, I have the solutions for parts A and B. You don't have to do this the way I do it, but I do tend to spend just a little bit of time doing a setup. If I see a problem like this, or I have to do sine, cosine, and tangent, I'm going to need all these values. I might just save a little processing space in my brain by doing them initially, and then just kind of double check them. Keep in mind that tangent is sine over cosine. So you should make sure that those are correct. I actually wrote the reciprocal for tangent when I wasn't paying attention earlier. But you can get all of those. Another thing is just, since we're in quadrant 2, verify that 12 is a negative 12 since we are moving to the left. Now, if these ratios in the final answer did have a factor in common, you would need to reduce them, but they don't. The tangent one has just a little more simplification, so I thought I would go through that with you. So keep in mind that for the tangent formula, on the numerator, we will keep this a sum because we're starting with a sum, but on the denominator, it'll be 1 minus tangent of alpha times tangent of beta. So I have it set up here. I am going to get a common denominator. You can pick how you want your common denominator. It could be 12, but I am noticing on the denominator that maybe it'd be helpful to keep it a 48 because on the denominator I am going to have a 48 as I multiply here. I mean, I could end up reducing this down and getting a 16. But anyway, I decided to do a denominator of 48. Not that you have to, but so I then multiplied this one by 3s and this one by 4s. I thought long term I might be able to reduce out some things a little bit simpler. I end up with, oh, that is not 48. This would be times 12. Let's try again. You could have gotten a denominator of 12. I think this one actually simplifies nice this way. So I end up with 36 over 48 minus 20 over 48, which ends up being 16 over 48. On the denominator, I have 1 plus 15 over 48. Well, if I get a common denominator with the 1, that's 48 over 48, which ends up equaling 63 over 48, and that reduces out, and I get 16 over 63. Now, wait a minute. Don't those numbers look familiar? The 16 over 63. I mean, you totally could do it this way, but think about what else we know about tangent. An easier way to do this problem. So like you could do it this way, but the easier way, in my opinion, is to recognize that the tangent of alpha plus beta is going to be the sine of alpha plus beta divided by the cosine of alpha plus beta. And we already found those. So this would be negative 16 over 65 over negative 63 over 65. The denominators cancel, as do the negatives. I think that's way easier than using the sum formula for tangent. Now, if I hadn't already done the sine and the cosine with the sum formulas, I think maybe the tangent formula would have actually been easier. But there are times where you can think about some of the other things that you know, and you might be able to find an easier way. That is it for this video for 5.2 day 2.